This is a demo of the BTBerryWifi Android app. This app lets you connect your phone or tablet to a Raspberry Pi via Bluetooth. It allows you to enter Wi-Fi credentials on your phone, which are then transmitted to your Raspberry Pi, which then connects to the desired Wi-Fi network. This is useful if you are running your Raspberry Pi in headless mode without a keyboard and mouse when you need to set a new Wi-Fi network on your Pi. From the Start screen, click on Scan for Raspberry Pi. This is the scanning screen. It displays the current app version, which is the free version when you download the app for the first time. This version allows you to verify that your Raspberry Pi is correctly set up and that you can set a Wi-Fi network on it. You can upgrade to the standard or premium versions to add functionality. Note that these are one-time forever purchases, not subscriptions. In this demo, we are using the premium version to cover all functions available. Now, back to the scanning screen. Your device displays the host name of any Raspberry Pis that are located with the applicable BTWiFi set Python code and that are in Bluetooth range. Here, 2 Raspberry Pis are detected. Clicking on one starts the connection process. Depending on the device, the connection can take anywhere from 10 to 20 seconds to 2 minutes. The connection progress is displayed. First, the Bluetooth connection is established. Then, your device is registered to receive messages from the Raspberry Pi. Finally, the list of all Wi-Fi networks seen by the Raspberry Pi is received from the Raspberry Pi. When the list is complete, the main Wi-Fi connection screen is displayed. The top line displays the host name of the Raspberry Pi to which you are connected. The next line allows you to turn off the Wi-Fi on the Pi, useful if you want to prevent it from joining any Wi-Fi network. The next line shows the Wi-Fi to which your Raspberry Pi is currently connected. This line could be blank if you have no Wi-Fi network set up on the Raspberry Pi just yet. You can disconnect from the connected network. When you do, you find that the network now appears under the list Your Networks. These are the networks already set up in your Raspberry Pi. You can connect to those by clicking one and selecting Connect on the next screen that appears. Upon connection, you are taken back to the main Wi-Fi connection screen, where you can see that the network you selected is now connected. You can then connect to another known network and will find upon the successful connection that you have connected to your choice of network and the previously connected network appears in the known network list. Although not shown in the demo, if the password has changed on the router for a known network and your Raspberry Pi has not yet updated it, you will be provided with a password text box where you can enter the correct password. Once connected, the password will remain stored on the Raspberry Pi. Finally, if you have the premium version, you can remove a network from the Raspberry Pi. This deletes all information, including the password, from the Raspberry Pi. Upon returning to the main Wi-Fi connection screen, you will find that the previously known network, in this case Home 6612, is now displayed in the Other Networks list. This lists all networks that are seen by the Raspberry Pi for which the Raspberry Pi has no information. These are typically networks to which the Raspberry Pi has not connected yet. Let us connect to the unknown network, Home 6612. Tapping on the name brings up the password screen. After entering the password and tapping Connect, if the connection is successful, you are back to the main Wi-Fi screen, which now shows this network as connected. If you select a network for which you do not know the password, you will receive a failure message after trying to connect. The last item at the bottom of the screen, Use Hidden SSID. This feature is available to standard and premium users. If the network you want to connect to is live but does not advertise its SSID, it will not be displayed in the list of known or other networks. Tapping this item will allow you to enter both the SSID name and the password of the hidden network and connect to it. Let us now look at the additional functionality available to premium users. Tapping the Lock icon at the bottom of the screen takes you to the locking and encryption screen. Normally, the SSID and password data you enter is sent from your Android device to the Raspberry Pi in clear text. This is fine for home or private settings, but could become a problem if you are in a public space or an apartment building, because Bluetooth transmissions can be monitored by third parties that are using so-called Bluetooth sniffers. It is possible to lock the Raspberry Pi by entering a password that will then ensure that all transmissions are encrypted. The password is created on the Raspberry Pi, defaulting to the host name when the Python code is first installed. The correct password has now locked the Raspberry Pi, and Bluetooth transmissions are now encrypted. You can unlock and relock it without having to re-enter the password, which was saved on your device. Now, other users of the BTBerryWifi are locked out and are prevented from connecting to your Raspberry Pi successfully. Clicking the back arrow at the top of the screen brings us back to the scanning screen, disconnecting the device from the Raspberry Pi. Let us demonstrate what happens when the Raspberry Pi is locked and another user tries to connect. Upon establishing a connection, if the device does not have the correct stored password, it is immediately disconnected and a password box is shown. Entering the wrong password will always come back to this password screen. Entering the correct password will resume the connection process and allow the authenticated user to reach the main Wi-Fi screen. With this feature, you control who has the ability to change Wi-Fi settings on your Raspberry Pi. The final premium feature is the info screen. Here, additional useful information is displayed. If the Raspberry Pi is connected to a Wi-Fi network, the first section displays the IP address, IP4 and IP6 versions. It is useful if you need the IP address to establish an SSH session, for example. The second section displays the MAC address of the Raspberry Pi communication devices. The third section serves as a simple network analyzer, displaying all the networks in the vicinity, their signal strength, channels, and frequencies. For example, this function came in handy when a neighbor Wi-Fi-enabled sprinkler system interfered with our Wi-Fi network when the Raspberry Pi was located in a back room that was closer to the neighbor's lawn than to our own router. It was easy to see the signal strength of both the sprinkler and our router on the same channel. A change of channel on our router solved the problem. Finally, the Your Other Info section displays any real-time info you have set up coming from the Raspberry Pi. This is configurable in the Python code on the Raspberry Pi. Currently, it is set to display the memory usage and the CPU temperature on the Raspberry Pi. Refreshing the information in the demo shows that you are seeing real-time information. This concludes the demo of the BTBerryWifi Android App, which allows you to set the Wi-Fi network on your Raspberry Pi via Bluetooth using your Android phone or tablet.